Hello students, and in today's class we are going to talk about the calculation of pH of a solution. How to determine the pH of a given solution. And first of all, what's the meaning of pH? pH is nothing but power of hydrogen ion concentration. Power of hydrogen. Actually, the pH is defined as follows. Negative logarithm of hydronium ion or hydrogen ion to the base 10 in a solution. Negative logarithm of hydronium ion concentration, otherwise hydrogen ion concentration, to the base 10 in a given solution is called pH. So pH is expressed as follows. pH that is equal to minus logarithm of hydronium ion concentration. Otherwise we can say pH that is equal to minus logarithm of hydrogen ion concentration to the base 10. Log base 10. And before going to the details of pH, we should know the different type of solutions. First of all, neutral solution. Neutral solution in which always the hydrogen ion concentration is exactly equal to hydroxyl ion concentration. See this case, the square bracket is denoting the molar concentration, also known as molarity of hydrogen is exactly equal to the molar concentration of OH minus, or we can take the normality of H plus is equal to the normality of OH minus. The concentrations are same. The hydrogen ion concentration is 10 power minus 7. Hydroxyl ion concentration is also equal to 10 power minus 7. So if you find a negative log for this 10 power minus 7, pH is equal to 7, and when you take the negative logarithm of hydroxyl, the pOH is also equal to 7. It clearly indicates that for a given neutral solution, pH as well as pOH is exactly equal to 7. And we can have the other category. Now, the other type of solution is acidic solution. Definitely in the acidic solution, the hydrogen ion concentration is little bit greater than that of hydroxide ion concentration. So here the hydrogen ion concentration, probably it would be greater than 10 power minus 7, and the hydroxyl ion concentration would be lesser than 10 power minus 7. Once the hydrogen ion concentration is greater than 10 power minus 7, if you calculate the pH, pH will become equal to or will become lesser than 7. And what about the hydroxyl ion concentration? If you take the negative logarithm of this, we can have the pOH that would be greater than 7. See, in a neutral solution, both pH and pOH are same. But for a neutral solution, for acidic solution, the pH is lesser than 7 and pOH is greater than 7. The reason is This is the reason. Hydrogen ion concentration is greater than 10 power minus 7. So if you take the negative log of 10 power minus 7, you can have less than 7. And the hydroxide is lesser than 10 power minus 7. If you take the negative log for this, you can have the pOH value that would be probably greater than 7. And the last case, it is a basic solution. In the case of basic solution, we can say that the hydrogen ion concentration is lesser and the hydroxide concentration would be greater. So I can say that the hydrogen is lesser than 10 power minus 7. Due to that, the pH would be greater than 7. And the hydroxyl ion concentration is greater than 10 power minus 7. So pOH would be lesser than 7. Very simple thing. So there are three type of solution. Neutral solution, in that pH as well as pOH, both the values are same, 7. But for an acidic solution, pH is less than 7 and pOH would be greater than 7. And for a basic solution, pH is greater than 7 and pOH is lesser than 7. And we are going to see how to calculate the values of pH and pOH for different type of solutions. pH of a given solution can be calculated as follows. pH of a solution can be calculated as follows. We can have a proper study on the pH calculation. For our discussion, first of all, we are going to take the stronger acids. For them, how to calculate pH. Stronger acid in the sense all your mineral acids like hydrochloric acid, sulfuric acid, nitric acid, phosphoric acid, pyrophosphoric acid, something like that. So for all your stronger acids, the hydrogen ion concentration, which means the hydronium ion concentration in the given solution, is nothing but, or it is equal to its normality. Try to understand. Suppose the concentration of the hydronium as well as the hydrogen, both things are same. If it is given in the molarity, then how to calculate the hydronium ion concentration? If you are given the molarity, better it is to be multiplied by basicity. Try to understand. If the normality is given for a solution of hydrochloric acid or sulfuric acid or nitric acid, the given normality can be treated as the hydronium ion concentration or H plus ion concentration. Instead of that, if you are given the molarity, better you multiply that by basicity. Then only that becomes equal to the concentration of hydronium or H plus. Why? I will explain. We know the normality that is equal to number of gram equivalents of a solute by volume of the solution in liters or in the decimeter cube. How do you calculate a number of gram equivalents? number of gram equivalent is nothing but mass divided by equivalent mass into 1 by volume. So this is the meaning of normality. And what about the molarity? We know that molarity that is equal to number of moles of a solute given substance divided by volume of solution in the same liter or in decimeter cube. How do you get a number of moles? It is nothing but mass divided by molecular mass of the given acid into 1 by volume. And we know that always the equivalent mass of an acid is nothing but molecular mass by basicity. So see this area, normality. In this expression, I am going to make a small change. The normality is equal to, I can say, mass divided by molecular mass, that is divided by the basicity into 1 by volume. Simply this equivalent mass is replaced by molecular mass by basicity. And we already know that the molarity of a given acid is mass by molecular mass into 1 by V. Yes, you can see the same is present here. So what is this term? This highlighted area, it is nothing but molarity. Now the basicity is in the second denominator, it can be taken to the numerator, and hence I can write normality that is equal to molarity into basicity, because this basicity, what is present in the second denominator, is taken to the numerator. So this term is replaced by molarity. And this is the relationship in between the normality and molarity. Because of this relationship, we must take molarity into basicity. When it is given in the normality, directly you can treat that as a hydronium ion concentration. Based on this idea, we can do the calculations now. The pH of a stronger acid. The pH of a stronger acid, pH of stronger acid can be calculated as follows. We will try to find the pH of stronger acid. pH that is equal to minus logarithm of hydronium ion concentration or hydrogen ion concentration to the base 10. And we have discussed that if you are given a normality, it can be treated as the hydronium ion concentration. Otherwise, if you are given the molarity, better you multiply that by basicity. A simple calculation you will make. Calculate the pH of 0.001 m HCl solution. Yes, if it is given, then what will you do? pH that is equal to minus logarithm of hydronium ion concentration to the base 10, and you are given the hydronium ion in the molarity. When the hydronium ion is in molarity, we have discussed that the molarity is to be multiplied by basicity of the acid. What do you mean by basicity? The number of replaceable hydrogen ion. The HCl is containing only one replaceable hydrogen. So I can take this as 0.001 basicity is 1. So it is 0.001. It is nothing but 10 power minus 3. Yes, scientifically 0.001 can be written as 10 power minus 3. Yes, if you want to find a pH, better you take negative logarithm of 10 power minus 3. Then what will happen? Minus is kept out of the bracket, and when you take the negative logarithm of this 10 power minus 3, yes, based on that power rule we can say minus 3 into log 10. Minus 3 is kept as such, and log of 10 is equal to 1. So minus is taken into the bracket and the pH value is equal to 3. And from the lower classes onwards we have studied that when the hydrogen ion concentration is equal to 1, the pH is equal to 0. Because if you take the negative log of 1, pH can be taken as 0. When the hydrogen ion concentration is 0.1, now the pH is equal to 1. When the hydrogen ion concentration is 0.01, now the pH is equal to 2. When the hydrogen ion concentration is 0.001, then we can say pH is equal to 3. See this decimal point. 0.1, pH is 1. 0.01, there are 2 digits, so pH is 2. After this decimal point, we are finding 001, 3 digits, so the pH is equal to 3. It's a simple problem where we were calculated the pH of 0.001 m HCl solution. Is it? And in the next problem, we are going to calculate the pH of 0.001 m H2SO4 solution. Previously hydrochloric acid, presently it is sulfuric acid. And you are given a molarity. If it is given the molarity, it is to be multiplied by basicity in order to get the hydronium ion concentration or hydrogen ion concentration. So I can say the hydrogen ion concentration given molarity is 0.001 and basicity is 2, as it is containing 2 replaceable hydrogen atoms. So this can be given as follows: 0.002, that is scientifically written as 2 into 10 power minus 3. And we have got the hydrogen ion concentration. Then we will be calculating the pH, that is equal to minus logarithm of hydrogen ion concentration to the base 10. So I can say minus logarithm of 2 into 10 power minus 3. Open a bracket, and inside the bracket I can split this as follows: log of 2 plus log of 10 power minus 3. And even this can be written as follows: log of 10 power minus 3 plus log of 2 for our convenience. And in the next stage we can write pH, that is equal to, I am writing a bracket. Inside the bracket this 10 power minus 3 can be rewritten as follows: minus 3 into log 10 plus the log of 2 is, it's a value 0.3010. 0.3010. That value is known for us. And we can say pH, that is equal to, I am writing minus 3 into log of 10 is equal to 1 plus 0.3010. Now the pH, that is equal to, the minus is taken into the bracket, minus into minus plus, and this minus is multiplied with this plus, so it is minus 0.3010. If you simplify this, you will be getting pH, that is equal to 2.6990. That would be the answer for this particular problem. So in this calculation, we were seeing how to calculate the pH of sulfuric acid. In particular, if you are given the molarity. Molarity means that should be multiplied by basicity. So here it is a sample problem. Okay. In the subsequent video classes, we have to discuss about the calculation of pH for weaker acid, stronger base, weaker base in 3 different video classes. Okay, thank you.